Hello everyone. Let us now discuss how can we solve this problem. Find the count of good integers. So we are given with two positive integers n and k, and integer x is called k palindromic if x is a palindrome, x is divisible by k, and integer is called good if its digits can be rearranged to form a k palindromic integer. For example, for k is equal to 2, 2020 can be rearranged to form the k palindromic integer 2002, whereas 1010 cannot be rearranged to form k palindromic integer. Return the count of good integers containing n digits. Note that any integer must not have leading zeros neither before nor after rearrangement. For example, 1010 cannot be rearranged to form 101. So what they are saying is, let us take something like n is equal to 5. That means we need to create an integer with 5 digits, placing some digits in these places, and k is given as 5. So after something like this, number should be divisible by 5. That means k, and the remainder, that means it should be divisible by k. Okay, now if I have something like 5 triple zero triple zero 5, and it is exactly divisible by k, which is 5. Now I need the total number of combinations. That's it. I need the rearrangements. How can we rearrange these digits, right? If I say 5, 0, 0, 5, and then 0, right? This is one another rearrangement. Now 5, 0, 5, double 0, 5, double 0, and then double 5, triple 0. So these are the combinations. Now you might ask me, is 0, 5, 0, 0, and then 0? We have three zeros and two fives. Is it okay to place it? No. We are asked not to have a leading zero. So what happens if I have a leading zero? Then this will become just a 4-digit integer. So that's why to make an n-digit integer, we need to ensure there should be no leading zeros. So the formula for permutation and combination is something like, if I write it, if we have something like p as number of digits, right? Number of digits 1, 2, 5. Here I have 0 and 5. P as number of digits, and uh, then I have Q, R, and S as frequency of every digit, right? Then then number of combinations, or if I write it, it is something like permutations, right? Permutations are p factorial by q factorial into r factorial wait a second, r factorial into s factorial, and if I have another things, and so on. Now this means, what does this mean? I am having 1, 2, 3, 4, 5. P is number of digits here. Here, if I say number of digits to be placed, that means here it is simply P is nothing but n. Now I have n. So imagine I have something like 1 for one time, and 5 for two times, and also 0 for two times. I am simply going to the formula, which is the core thing in this question. So I am having 5 for two times, 1 for just one time, and 0 for 2 times, right? At this point, as I am having repetitions, I cannot say 5, 5, 0, 1, 0 is another combination, and simply I cannot say that 5 is here, this 5 and this 5 are replaced. This shouldn't be something like a dumb statement that 5, 5 are replaced. These two are replaced, and this is my new number with 55010. So this is absolutely wrong. That's why what we are doing is 5 factorial, total number of places that we need to fill, by 2 factorial into 1 factorial is just 1, and then 2 factorial again. So I am multiplying the denominator with the frequencies of every digit. So this is how you get every digits, every permutation. Now there is a case that 0 can be placed at the first index, right? Then how many indices we are left with? Just 4. When we are having 5 digits, 5 places to be filled, we got 5 factorial by something. Now we have 4 places to be filled, and 0 is the constant place, and that will not be changed. Let me tell you what and why I am doing this. 4 places need to be filled, right? 4 places need to be filled. Okay. Now I have 5 for 2 times and 1 for just 1 time, and here 1 0 is already taken. Then how many zeros I have left with? Just only 1. So 2 factorial into 1 factorial into 1 factorial. So if I remove this 4 factorial by 2 factorial into 1 factorial into 1 factorial from 5 factorial by 2 factorial into 1 factorial into 2 factorial. This means total combinations minus the combinations or the permutations with leading 0, only 1 0. That's it. So this is how we solve this problem. Like, this is the core intuition. Now how do I generate palindromes? Something like palindromes, right? How do we generate palindromes, right? So to generate a palindrome, let us see what is a palindrome for those who don't know what is a palindrome, right? I have 1, 2, 3. Then if I read a number from starting, this is 1, 2, 3, 2, and then 1. Now I am reading this in reverse, right? If I read this in reverse, and I am taking every number which I read reverse, like I got 1 first, I got 1, and then I got 2, and then I got 3, and then I got 2, and then I got 1. See here, these two are same. So this is called a palindrome. You might ask, what if I have one, wait a second. What if I have 1221? So this is also a palindrome. When I read from reverse and also from forward, then I will get the same 1221. And if I read from reverse, 1 and then 2 and then 2 and then 1. Okay, now we know what is a palindrome is and how do we compute. If I got a palindrome, this is something like 50105. If I got any palindrome like this, I am counting these permutations. So my intuition is getting a palindrome, right? Intuition is, first thing is taking palindromes, and the second thing is taking the count or permutations for every for every wait a second, for every permutation, like something like Wait a second. Here I am having something like 50105. Now, this 50105, how many places we can change? That means how many permutations that we can get by 50105. This is about taking the count or permutations for every number like 50105 or any integer. If I something like say as any good number, right? Now, I have something another to do in the algorithm. Here, I will compute all the factorials till 9, and also I'll store them, and then I am doing something like in this string. Now, I have n is equal to 5. What is the first place or first integer that starts with digits, number of digits as 5? I think let us go with the last one first. No, right? I have 9, 9, 9, and a 9, and then 9. Now, this is the last integer with having 5 digits. Now, what is the first integer which is having 5 digits? 1, double 0, double 0. So, what I need to do actually, if I go from here to here, then it would take much time, as they might give something like 1 or 9 is the last number of in the constants of n. So n can be till, sorry, n can be till 10. So it would take something like, wait a second, it would take something like from 10, it would take a much time, and we will result in a time limit exceeded. Instead, what I do, if n is odd, I will take the first three characters or first three characters, like n plus 1 by 2 characters is called half. Wait a second, here it is half. So so I am having here half is the size of current something like n by 2. So when I got something like here, instead of getting uh, odd and even, so I am placing it like n plus 1 by 2 for half. Now, what the algorithm does is going till only half, right? It places only 3 digits, and I have another 2 digits here. What it will do is taking the numbers from, if I have 100. Now, it will do by taking this string for only half and reversing it. If I reverse it, then I will get 001. If it is odd, it will delete it. Delete, or it is the first character, then it will concatenate these two strings, 1 triple 0 1, and check whether it is divisible by k. And if it is divisible by k, then it pushes that palindrome into the palindrome vectors. So factorials till 9 is computed. Now I have vector for storing palindromes. Now I have a vector for storing palindromes, and another thing which I need to do is taking a string. String need to be from start start and till end, but we will take only the half the size and concatenate the reversed string. If if so, n will be something like here, number will be something like string to long of current string, as if num is divisible by k, then we insert this into palindromes. Now I have got all those palindromes. Now I need to do something like for every palindrome in palindromes, I will take a vector int, or I am taking something like unordered map of character comma int to get the frequency of every character, and I am taking total count minus count with leading 0. Don't worry and don't be confused if in the code I have given the different variable names. Just variable names have changed, but the approach is same. Total count minus, so here it might be something like uh, count, I think count minus count with zeros, or all count minus count with leading 0 will be the total count plus is equal to this all count minus count with leading 0. Now here I have total count, then I will I will do something like returning the total count at the end. So all count and count with leading 0 is already explained when I said this here. So this is the total count and this is the count with 0, leading 0. So if I do a subtraction here, then I'll get all the permutations, and I have given the code link in the description. Go and check it. If you like this video, do share to your friends and do subscribe to my channel. Thank you.